look at Jesus's score again. He was at a 2.14, and we kind of wonder, what percentile did he score at? We don't really know, do we? Because we kind of know we have that empirical rule of thumb, and we can kind of say, well, if we're over here 2 standard deviations above the mean, we know that in this region here that we're going to have about 95% of the data. And then we know over here is going to be 2.5%. And so he's scored better than 97.5. So we can say he's at approximately the 97.5 percentile. That's using the rule of thumb. But we have some other ways that we can do this that will give us a more precise answer. And so we can use a table, and I think I'm going to focus on showing you this table instead of this Excel or Google Sheets function, because that is not really available when you're taking a test, but the table is. So let's take a look at this table and see. This table shows us that from 0 to whatever number you look up on the Z parts, you will get this area that's shaded. So from 0 to whatever Z score you look up. And every table is going to be different in terms of what region they give you a Z score for. So you have to kind of look at it and see what it's showing you. Now, the thing that we do to make this table super useful is we remember that our distribution is symmetric about that mean. So right there in the middle, if we fold it, we're going to get the same thing on both sides. So if you really wanted to know an area on this side, you just think about folding it over and find that same Z score to the right and make it positive, and then you'll have the area for that left-hand side. Areas are like the square footage of a house. You never have a negative number. Now, they also aren't rectangles up here like a house is. So you can't just take one standard deviation and say that the second one will be the same size, because you can see here that it gets smaller and smaller on the top edge, and this table takes into account the curve, and so it gives you the value, but you have to figure out kind of carefully what the area is from one Z score to another. So let's take a look. If we're going from 0 to, in this case, we were looking for Jesus's score. He has a Z score of 2.14. So if we look at the table, we come down the left side where it says Z and keep sliding down until we see 2.1, because it was 2.14. So we take the first 2 digits and we're looking here in the 2.1 column, and then we go over to, this is 2.10, 2.11, 2.12, 2.13, 2.14 right here. And if you track that straight up, make it a little bit smaller so we can see that we have this 0.04, and we just go down, so we're just making a rectangle with it. And where the 2.1 is plus the 0.04, we can think of it that way. 2.1 plus 0.04, and that'll give us the 2.14. And so that's what this value here is telling us, the area. If you go all the way on a mound-shaped distribution all the way to 2.14 from 0, that this area here inside that shaded part is going to be 0.4838. Okay, that's what the table is telling us. From 0 to that Z score that we look up, that's the area under the curve. Okay, so let's come back here, and we can see our nice mound already drawn for us. Someone got tired of seeing Mrs. Brown's really terrible mounds on this. It's the input device that I'm using. It's hard to draw it, but I do better on plain old paper or on my other computer. But We are going from 0 to 2.14 for Jesus, and this is what we drew on the other page, and we're finding the area here. And we found this area to be 0.4838. Now, we want to know the whole left-hand side, right? Because we know he scored that well, but there's all this stuff over here too. And so we're wondering, well, what about all that? Because it didn't get added in. Well, that's where the symmetry comes in, because right in the middle, that's half. So if you take off one side, or we're only looking at this side here, that side that I have highlighted, that is half of your distribution, right? Just like we were working with before. So that is half, and so that has 0.5 for its area, because the whole curve has an area of 1. Remember that? That was one of our criteria for a mound-shaped distribution, a normal distribution. The half of it has an area of 0.5. So we have over here 0.5, and over here we have 0.4838. I think that was the right number. Let me check one more time. 4838. And we want them both, so we will add them both up. So 0.5 plus 0.4838, and we get 0.9838, and that is not as a percent, it's as an area, but it is equivalent to, just multiply by 100, it's at the 98.38th percentile, because to the left of this marker is 98.38% of our data, right? And that's the definition of percentile. To the left, we have 98.38%, so that means that Jesus's test score is at the 98.38th percentile, putting him way above most students who take the test. Remember, we said 97.5 percentile, and why were we off by so much? Well, it's because we only counted to 2, because that's what empirical tells you, only up to 2, but he's over here at 2.14, so there's a little bit of extra area in there. And then the other thing is that this empirical rule is a rule of thumb. It's not nearly as exact as if you can use the z-scores table. So the z-scores table is going to give you more accurate results.